Hi folks, Tom Affolter back again, and today we're going to be talking a bit about understanding C# object-oriented programming terminology and some concepts associated with that. For you to be able to continue on with this project, I have a couple of expectations. First of all, I would expect you to have a basic understanding of C# programming principles, things including understanding of variables and variable scope and logic. And I also would expect at this point you understand how to incorporate methods. Methods including functions or void methods or even event handlers. If you don't have a background on that, I'd highly recommend you go back in and listen to my lecture on methods themselves. So in the past, when I got involved with computers, back in the early 1980s and late 1970s, we were dealing with what we call the third generation of programming languages. Third generation of programming languages were really the first business-oriented type programming languages that came out. They included those languages such as BASIC and COBOL, Pascal, Fortran, and C, for example. And these languages, what we refer to as procedural languages. Procedural languages were very large programs typically that flowed top to bottom, unlike today's object-oriented programming approaches that we're going to be talking about. So again, they were very large programs relative to the memory, I should say. They weren't large programs as we might think of in terms today, but when you had computers that were running 16K of memory or even 256K of memory in early days, programs tended to take up a large amount of the memory. They became very difficult to manage and to debug. As time went on, programs stayed the same. COBOL was COBOL, Pascal was Pascal, but the computers started to get a little bit more capable. They started to run faster, we had more memory. At that point in time, the language may not have changed, but the size of the programs started to change. So they got really large. Finding an error perhaps in the 20,000 lines of code became very, very difficult. And in fact, in those early languages, if you had one error in the beginning of the program, sometimes it would come back and report that you had as many as 1,000 different errors. You declared a variable incorrectly at the top of the program. Every place in that program you might get back an error message saying there was an error on this line or this line, when in fact there was one error altogether. In the early days, libraries were unavailable as well, or very limited. Libraries were chunks of code that you could buy that somebody had already written for you that did a particular feature. Applications didn't have those libraries in the early days. Here's an example of a basic procedural programming language program that was written. And you'll notice on the left-hand side you have line numbers 10, 20, 30, 40, 50, 60, etc. And then you have your code on the right-hand side that's written. The line numbers indicated the order of execution, and the reason you numbered them by 10 was to have the ability to go back in there and put a line 15 in, for example, or a line 25. And then you could renumber them if you want, and it would renumber them by 10s again. But they always flowed top to bottom. So this top first line would be line 10. There were if-then-else statements that changed a little bit of the structure around, a little bit about how it moved, and there were some statements called go sub statements and go to statements. But for the most part, the program flowed just like a series. If you had a series of 3x5 cards and you just started thumbing through them one by one, maybe one of the cards might say skip 5 cards, but nonetheless, you always go from the top card and you end up at the very bottom card. The top card being the start of the program and the bottom of the card being the end of the program. The concept of object-oriented programming has been around for quite a while. In fact, it's really interesting how it came about. Originally, the object-oriented programming concept was developed in the early 1960s at Massachusetts Institute of Technology, and it was used in a simulation programming language, not a true programming language as we know today, and it was called Simula. And what it was really geared for was it was an on-paper simulation of exploding ships. I believe it was the Norwegians that wanted to know how much ammunition or how much explosive would it take to blow up a particular ship, and this was a prototype that was used. It really didn't come to fruition as we understand it until about the 1980s when the first two languages, Java and C++, incorporated the concept of object-oriented programming into their design. And why did they do that? Well, they did it because they wanted to break up these really large programs into small subset programs. Subset programs called classes that work with each other and objects that work with each other. Although, as far as the computer is concerned, the program, the ones and zeros look the same, We as programmers, though, had to change concepts or ideas of how we wrote programs, and I will tell you, as one programmer who went from procedural programming to object-oriented programming, it was a pretty difficult step for me to go from thinking procedurally into thinking object-oriented, because when I started learning object-oriented programming was about 1992, 1993, and I was learning it on Java, an early form of Java, and there was nobody around to ask questions. There was nobody to explain any of these topics. I had a book and I had an instructor who didn't really even know Java. It was that new. But Java was really the first environment that I got involved with. So the purpose of object-oriented programming really, again, is an attempt to organize these large programs into manageable, smaller objects. And it makes debugging and programming itself much simpler. A simple program you might develop today that might consist of 1,000 lines of code might take 100,000 lines of code to produce that same exact results had we been writing it in the early procedural programming days. Why is that? Well, in the early days, we didn't have forms that we could drag onto the screen or text boxes that we could drag on. If we wanted to create those objects, we created them completely by hand, which means that a text box might take me a couple of days to create a functional text box that we might know today, whereas now, that's just a tool that I can drag onto my form. So in the past, we thought of a program, again, as a single entity. You gave the program input, the program would calculate the answer, and then the program would give you some kind of output or some kind of an answer back. Now that's really what the early programming languages like Fortran were geared for. Fortran stands for Formula Translator. It was really a programming language made for engineers where you could input a formula, pass in a value, and have it kick you back an answer. Today we look at programming, though, like a puzzle that's being assembled to produce a final program. In the early days of procedural, we saw a program as one giant entity. Now what we see is a program that's made up of each separate little piece of a puzzle, and each piece of that puzzle has a responsibility. A button has a responsibility. A text box has a responsibility. A combo box has a responsibility. And each piece of that puzzle we're going to give a unique name to so we can identify it. I can refer to the name text box, or the address text box, or the answer label, if you will. And each piece of the puzzle can interact with any other piece of the puzzle. So I can click on a button and have that button change maybe what's in a text box, or change what's in a label, or change the background color of the form. So these pieces of puzzle, or these little chunks of code, or methods, as we'll talk about, can interact with other pieces of the puzzle, and ultimately all these pieces together function as one single program. And in the past, where we had to create everything, today I find that about 50% of what I need to create to put into a program has already been generated on my behalf. I just really have to go back in and put the logic of my program. So let's talk about the concept or component approach. An automobile is a really good example of a component approach because the car has subcomponents. We can look at a car and say the car is an entity, but we can also look at a car and say tires are an entity, or the engine is an entity, or the transmission, or the body. But every one of these components in a car work together. For example, the transmission turns the tires, which moves the vehicle. Even though the transmission is a separate object entirely, by putting it together with all these other objects, we create the car, which causes combustion, which causes that car to move. The components, again, as I mentioned, work together. So that engine drives the transmission, or the steering wheel would turn the front tires. This lecture is going to cover the components and how those classes are going to be designed from scratch. Up to this point, we've been using pre-designed classes, text boxes and radio buttons and forms, and we've been adding the event handlers in ourselves. Now we're going to go back in and take a look at designing these entities on our own. So the world as a whole, you need to look at it from an object-oriented approach. Everything that we deal with in this world is an object. A house, a car, an avatar, car loan, or a photo. Everything that you look at, can feel, can touch, that technically is an object. A tangible object is one that you can see or you can touch. An example of that would be a text box or a button. You see a button on the form, you can click it. You see a text box on the form, you can click on it and type information into it. Objects can be tangible items, like a car, as I mentioned, or a desk, or a teacher, or a map, or a button. But in programming, we commonly think of tangible objects, though, as those things that we can feel or touch. But that's not the only objects that we deal with. We also deal with things called intangible objects. An intangible object are things that are there, and you know they're there, and you can test for them being there, but you can't physically see them, like you can see a text box or a radio button. An example of an object that you might not think of as an object, but it actually is, would be an internet connection. An internet connection is an object that we can control. I can connect through the internet using that object. I can give it an IP address or a domain name or whatever, and I can interact with that internet object. A timer is an intangible object. You don't see a timer, but you know a timer is there because you can set the time and it runs out and it does something. Processes are common. A process that manages a building's environment, that too could be an example of an intangible object. You don't see the process that turns on a heater or that turns on an air conditioner. It just happens behind the scenes. Another example of an intangible object, which is a very common one, would be a math problem. You don't see the math problem, but you can see the results of it. You know what you have to input for that math problem. You know what the math problem has to do to get the answer, and then a math problem kicks you an answer back again. All those same things that make up any kind of given object. And a loan. A loan, too, would be a really good example of an intangible object. You don't see a loan, but you can see the results of a loan, your car, your house. But a loan object can't be seen. You see the paperwork associated with it. You can discuss the loan. It's a noun. But you physically can't see the loan, but you can interact with that loan. The loan has a principal. It has an interest rate. It has a payment amount. It maybe has collateral that you had to put up to take that loan. So these objects tend to manage processes that can be described in an algorithm, but you can't see. And they're just as much an object as a text box or a radio button. You can't see an intangible object, but again, you can test for it and you can manipulate it as well. So what do we do with these classes? Well, a class can be a form of a Windows form and all the components. You can keep in mind that a class can be made up of other classes. A Windows form, for example, we've talked about before, is a container object or a container class. And we can put classes on top of that form. Text boxes, radio buttons. Class can also be a new tangible tool that you might add to your toolbox. You might look over and say, boy, I really like this text box that is here, but I think I can come up with ways that I can improve that text box. Maybe when a user selects that text box and is in focus, it's automatically yellow, but when they leave the text box, it turns back to its native maybe white background color or control color. Why would you want to do that? Well, maybe you've got 20 or 30 different text boxes on the screen and you want the user to just know immediately what text box is selected as opposed to try to figure out where that flashing cursor is at. You can use a class to hold simple values with no methods at all. We call that, and we're going to take a look at that later, a POD, plain old data. For example, say you've got a form that has 50 variables and you need to pass those 50 variables onto another form. Maybe it's a receipt form and you want to pass that across. What you don't want to have to do is go through and create 50 different individual variables that you would pass across. What you can do is create one class that will hold all those variables. You move the one class to the next form and you just pull the values out of it. You can also take a collection of public methods. We're going to talk about all of these in this lecture, and we're going to create a toolbox. A toolbox is something that you're going to want to use from client to client or from program to program. Something that you know you're going to want to reuse. An example of something I put in my toolbox, and I have a whole bunch of different commands that I built on in my toolbox. C# does not have a command called isNumeric. I want to know if I passed a string into it, I want to know, is it a number? Yes or no? And what I've done is I've created my own custom command, which again we will talk about in this lecture, added it to my toolbox, and every time I start a new application up, I can move that toolbox into that new application that I'm writing, and I have all my custom tools that I've created that have saved me time. Another thing that you're going to create, and we're going to really focus on heavy within this lecture series, is going to be a business object. And a business object, which really probably should be called a business class, but they call it business object as a whole, is really the heart of your organization. Let's imagine that you're working for a company where you have inventory control, you have accounts payable, accounts receivable, you've got general ledger, and you're making that available not only within your business to your desktop application, but you have a website that accesses that same data. Maybe you're selling products online that are being pulled out of inventory. Well, what you don't want to have to do, folks, is to have a desktop application, a web application, and maybe a mobile or phone application totally separate with separate code. Because if you change one rule in your business, how it calculates something, you would have to go to every separate program and make those changes, and that would be an utter nightmare. You don't want to do that. So rather, what you're going to do is you're going to create one class, and you're going to call it a business object, and that business object is going to have all the work that your business does. If you sell products, the product's going to be sold out of the business object. You're going to have a user interface that's going to interact with that business object, but all the work will be done from the business object. Let me give you a better example. Say that you are the U.S. Postal Service. They have desktop applications inside. They have web applications that you as a client can connect to. Again, you don't want to have to write separate apps. So what they've done is they've created one business object. Their whole business runs on one business object. Your web application connects to that business object. Your desktop app does. Your mobile or cell phone apps to it. Every application that you have, and they don't even have to be Microsoft applications to be able to run this business object. But the business object does all the work. And if you're the Postal Service, that's what the focus of this lecture series is going to be about, is how can you consolidate all of your business logic into one location and share it. Because once we create one of these objects, we'll be able to attach it again, as I said, to every other program that we write. So when you create a class, you can utilize others' classes through what we call inheritance or importing. When I drag a text box onto my form inherits all those characteristics that it needs to access that text box, and I have all the features of that text box. The text box that I drug onto my form now inherited all the features of that text box that was on that tool. So we imported it onto my form, or another term for that is instantiation. We'll talk about that in a minute. But the moment I put it on there, it inherits all those features. And you've seen me do this before, because I can also take a text box, throw it onto the form, change the background color of it, maybe change the alignment so it's right aligned. And then with that object on the form, I can copy it and paste it, and every object that I paste will inherit all the properties but one. The one property that will not inherit if it's copied and pasted is going to be the name property, because it will give a new name to each object that's thrown on the form. In Windows world, these classes are packaged in what we call DLLs. We're going to be creating DLLs within this module that we can import into our class. So when I create this business tool that we talked about a minute ago, this business object, I'm going to write it out to a DLL. Then I'm going to take that DLL, and all a DLL is a collection of one or more classes or tools. I can take that DLL now, and I can use that in or incorporate it or import it, if you will, into all my other applications. And later, if I go back and change that DLL, it immediately is inherited by all the other instances that have used it. I don't have to go back to each one of them and update anything again. When we design classes, we can subclass or make a new version of a parent class. When I'm dragging that text box onto the form, I'm making a new instance of that original text box class onto the form. And I can have as many of those text boxes that were created from that original text box as possible. We're going to talk about that in a minute. That is an amazing part of object-oriented programming and the inheritance. So going back and reviewing this concept of business object, a class can have properties and methods. We reviewed that over and over again. A business might build a class or a package of classes to centralize processing in a company. We talked about that as being that business object. These objects are known under a variety of different names. Things like we just talked about, dynamic link libraries, DLL. They might call them toolkits, libraries, APIs, frameworks. Ruby calls them gems. Microsoft most recently comes out with what they refer to now as nougats. They're all the same thing. So a company such as UPS has several tools common to both the customers and the employees, as I talked about a minute ago with the Postal Service. They have tools unique to their employees and operations by developing business objects that can link common sets of tools to their internal business applications as well as their website. Looking up the location of packages, figuring out what the cost of a package is going to be, insurance on a package, those types of things are all built in, and they're not going to put them in every single application they write. They're going to put it in one central location. Let me spend a couple of minutes here and show you some of the concepts that I'm talking about. First of all, when we start our initial application up, it's giving us what Microsoft would have us believe is a form object. And if you listen to most of the instruction, they're going to tell you that if I drag on, let's just do a couple items here. So if I drag a button on here and I grab on a text box right here, what they're going to have you believe is that we've now created objects. Technically, that's not true. It's not truly an object until right now. When I'm running it and it executes, this is my object right here. So this over here was a class, and these are instances. This is an instance of a text box class. This is an instance of a button class. But this is a text box object, and this is a button object. How do I know that? Well, because the object is the implementation, the use of it. So I'm not using it over here. I don't run this. I can change things in here, but what I'm changing is the design time properties of this. So these are not truly objects. But let me show you some examples of instantiation. One of the great things about this is that I can take this text box, and I'm not limited to a single text box. For example, I can drag another text box on this form, or I can grab another one on, and I have 3 different instances of these text boxes, and they're all using the default text box values or properties that are in there. If I take a look at them, every one of these objects are going to be exactly the same. The only thing that will be different is the screen location of where they're located on the screen, but other than that, the size is going to be exactly the same. The other thing that's going to be different will be the name. The first one by default is text box 1. The next one will be text box 2, and then of course text box 3. But they all inherited the capabilities or the characteristics of that default text box over here. Now let me prove though that I can change that. I'm going to get rid of those 2 guys right there, and what I want to do with this text box is I want to add a couple of features to it. Okay, what I'd like to do is I want to change the size of it, the font in it. So let's go back over to the font. Let's change the font from, I believe it's what, size 9 right now, 8. Let's change it to a size 12 initially. Let's make the text inside of it bold, and I'm going to use a Segio UI font for it. Okay, click that, and it looks pretty much the same, a little bit bigger. And let's change the background color as well of it. So I'm going to come back over, find my back color, and let's make it a yellow right there. So there's the background color of it. So now, if I drag a text box back on the form, you'll notice that they're different. Why? Because this text box derived the default value from this text box over here. But let me show you something cool. If I grab that text box and I copy him and I paste him, all the text boxes now are going to inherit the characteristics of this text box. Watch this. They're all going to be the same size, and they're all going to be yellow. So there's your example of inheritance. I'm inheriting the default value, but when I change this value up here, the properties, and I pasted, these guys by default will inherit the parent that was copied from. Now, once I get these copied, there is no relationship between these per se. They all have different names, but they do all have the same characteristics. You'll notice that if I open them up, they still all have that Segio 12-point font that I assigned to that original one right there. As long as I'm here, I'd like to take a moment though and go back in and take a look at the design of the class. We're going to come back in baby steps, look at this later, but if I look at the code here, a couple of things that you're going to notice. First of all, we've got this thing at the very top called a namespace. The namespace, you'll notice, is the same name as my solution up here. Notice it's demo objects here, it's demo objects down here. Then notice down here that the name of my form is form 1, and down here it's referring to it as form 1 for the class. So really what this guy is, folks, he's just the container. If I was to go back in and add in another project, which I could do, I can have multiple project solutions. Then the next solution would be demo objects.form2 perhaps. The technical name for this form 1 right now, and we're going to see it later, is demo objects.form1. It's the solution and then the class that's inside of that solution. But the most important part for us to look at right now is this guy right here. And I'm not going to worry so much right now about this public. We're going to come back and visit that here within this lecture series as well. But I do want you to notice this part right now. This part says we're going to create a brand new class, and that class is going to call form1. Here's the class on, and here's class off. Just like HTML has an HTML tag on and HTML tag off, the class starts here and the class ends here, and anything in between that class will be components of that class. And we're going to be talking about these guts here as well, as far as the program goes. Now, normally you have a single class, but what Microsoft has done here is, well, let me even back up a little bit. About 13 years ago, Microsoft had a problem. They used to embed the designer code and the code that you generate together on the same form, which meant that basically this code right here, would be put inside of this form right up here at the top. So you would have your complete application there, and it was a single class. Well, what Microsoft realized is that if you went back to this designer code right here, and you're a novice and you accidentally modify anything in here, your whole program would cease to operate. So they really don't want you touching, until you become an expert, the code behind. So what they did is they broke the code into two different chunks. They separated it out. They gave you what they refer to as a partial class. They both have the same exact name, and technically in the object-oriented world you have one class. But if you look at the very top of this, you'll see it says partial class form 1, just like we come back over here and it says partial class form 1. These two partial classes, when you go to compile them, are merged back together again as a single form 1 class when it's compiled. Microsoft just does that again to keep you from messing, I guess, if you will, with any of this code over here, because it'd be so simple for you just to cause a simple problem like, putting a letter in front of this and then going back to your form and having everything just disappear in your form. Notice all I did was I just added that S in the beginning of that, and everything I just put on my form disappeared. So I'm going to go back and delete that out, and we'll understand why that is a little bit later. So I'm going to put that, get the S out, and just by getting the S out, I go back to my form, and my form elements are back again. So there you go. There's an example of inheritance. We're going to talk much more about inheritance, and we're going to find out that a lot of the code that's being created in the code behind, we're going to understand a little bit more as this section goes on what is exactly happening within that code behind. Before I go, I do want to show you one other thing that I forgot to mention, and that is, let's look at references here. These are all the packages or all the tools that Microsoft adds in that allows you to write a desktop application. Things like the C# language out here. Data, if you want to have data connectivity. There's one here for HTTP if you were doing anything in your desktop application that required us to connect through an HTTP server where we might be grabbing HTTP services. Web forms, that's what allows us to have all of these different tools over here are the form elements. And some of these aren't being used. We're not using the XML and we're not using the link right now. The advantage, though, is by them being in here has no impact. When the program compiles, it's only going to use these packages that it needs to. If it doesn't need all these packages, it will not put it into the install program. Now, what are these guys made up of? If I was to go ahead and let's open up right now Windows Forms. So if I double click on this guy, actually, going to take a second here to open up. I'm going to get into what's called the Object Browser. You see Object Browser up here? And the Object Browser opens this up, and these are DLLs, by the way, folks, a Dynamic Link Library, and I'll show those to you in just a second. But if I take a look at this form here and I open it up, you're going to see that I have all of these different features built into it. You're going to see in here things like radio buttons, most likely, column styles, all at cursors, all these different features that we have to make up a form. All of these different entities in here will be part of these tools right here. So when I added in that Windows form, or when Visual Studio added in when it opened up a brand new package, I automatically inherited all the features that the system.windows.forms has, because I can utilize that. And let's say that there's some command up here I want to customize my environment, something up here that it doesn't do, maybe telephony to control a telephone system, or maybe something to control Windows Media Interface or whatever. I want to add additional tools. I might get them from Microsoft, or I might buy them from a third-party company, or I might find them free on the internet. How do I add the tools in? Well, it depends on the kind of tool. If you're adding a non-tangible tool, non-tangible, you're going to come back over here, you're going to do a right click, you click Add Reference, and after a moment you're going to see a screen pop open, and you're going to go over to Browse, and let me see what I've got here that I want to browse through. Assemblies, these are all packages that I can choose from. And everything with a check are packages that are currently in it. This allows me, folks, to customize my development environment. If I want to go back in and make my custom environment deal with telephony, then I can add the telephony package over here, and my application all of a sudden has all those features that the telephony class gave me. Before I go on, these guys are made up of one or more classes. So a package or a library or an API, they're all the same thing, folks, is made up of one or more classes. If I have a single class, I can compile it and I can come up with a DLL, but I can also put 5 different classes as I want inside of a DLL. How might I do that? Well, let's come back over here, and we talked about this a minute ago. Right now, this form, everything I've been working on is a class. And what I've got is I've got demo objects with a single class here. And it's this demo objects solution also has a demo objects project. And if I wanted, I could add in another project into here and would add another project below. So this could be one class. I could keep adding as many different classes in here as I want. When I compile it, it turns it into a dynamic link library, a DLL, and then I could use that DLL and incorporate it into my programs later. That's what you're going to want to do. We'll talk far more about that later. I wanted to jump back in and show you a little bit of these features before we continued on. So let's go back and review objects just a little bit. An object has those characteristics that we call properties. So if we're referring to a game that everybody is used to playing, we have a player object. And that player object has certain characteristics or properties. We might give that player a name. That player may have a percentage that represents power or speed. They may be a specific type of soldier. They may have a specific weapon type. And they may have a specific hair color, and on and on. Those would be an example of the individual properties that that character might have. But if we're referring to a loan, perhaps, that comes from a bank, or a loan object, which you can't see. Remember, you can see that character, but you're not going to see that loan object. That loan object might have properties, a name, what kind of loan is it, the date of the loan, the amount of the loan, perhaps, the interest rate, maybe some collateral that you had to put on that loan. So just storing a property is not enough. Objects have to perform something. They have to do something. They calculate a loan. They might play a video. There's a variety of things that they might do. Play a game. Whereas property relates to values needed by the object, methods is where the work is going to be done in your program. That's the logic. Properties are going to be accessed by methods. Properties are those characteristics. Methods can be returning in value. We call those functions. We've looked at those before. Or they can be void methods, if you will. They just go out and do something. An example of a void method would be an event handler. Okay, we have a click event. When the button is clicked, we go out, we do something, we jump back, and we continue where we left off. When we look at that loan object now, we've looked at the properties, let's talk about the methods that we might find in a loan object, where the work is done, where we actually do most of our coding. We have maybe a calculate loan method that's going to take all those properties that we fed into it and calculate what the loan is going to be, how much money you have to pay, perhaps the duration, what have you. Maybe part of that loan object is when you do a submission, we check credit. So you might have a check credit method that goes back and verifies that the person applying for the loan is authorized to get that loan. Maybe we might want to go back into an existing loan and get the payment history and find out how much payments have been made, get a total amount of payments to date. And maybe there's another method where somebody would call in and say, I would like to know what my payoff is on this loan. So we might have a method out there called get payoff, which would tell me the value of paying off that loan. In each case, the methods will refer to what we're going to call helper variables or properties that are going to complete the task internally. And we're going to talk a lot more about helper variables and properties in just a moment. They might also change the value of properties such as myloan.paymentsremaining. So properties are generally used for input into your object. A user sets the value of a property, but as we're going to see, the property is passed to the object to what we call a helper variable. As we will find out soon, properties are used for just a very, very brief moment, just to interface with the person using your object. But internal to your object, you will not use properties. I'll explain that in a minute. Methods are generally used for processing information, calculating answers, where the work is done, and we also use methods for displaying output, giving us the answers. You don't typically use a property to get back an answer, maybe the number of payments for a loan. You're usually going to return that back in a method, and we'll go through, demonstrate that, and get you in a habit of doing that shortly. If we're referring to a candy machine as an object now, which is really a good object, then the selection buttons would represent the properties. Grabbing the candy and providing it to the buyer would be the responsibility of the method. So you identify the candy that you want by pushing a button. When you put your money in, that initiates the method to spit the piece of candy out for you. As you're going to find out in the next section, there's a lot of different ways that we can code classes. As time progresses, you're going to develop your own techniques, generally as a result of the rules of the shop that you work with, or if you're your own boss, the rules that you establish yourself. We're going to find that there's white hat rules, which are the accepted rules, and black hat rules, which are sometimes shortcuts but are risky techniques. As a developer, you have a fiduciary responsibility to your clients not to put any of their data at risk, and you need to follow standard recommendation or standard methodologies. Within the next section that we're going to get into, I'm going to present to you those OOP principles.